Okay, so what are we gonna do? First of all, let's see. Go ahead, MK. Do you have a question? So which is the most accurate? That's a really good question, and it actually depends. But as a rule of thumb, midpoint is pretty good. And is usually better than right and left. And if you average right and left, you're usually going to get something close to the midpoint. But factually, if you do infinite rectangles, they will all give you the correct result, if that makes sense. And that's actually what we're going to do next time. Not today, but next time. We're going to talk about how do you do infinite rectangles? What does that even mean? How do we do that? And that's what calculus is about, right? So, but if you're just using a few rectangles, they're all kind of alright. And I'm actually going to show you Trapezoid Rule today, which is so much better. And there's actually another rule that you would fit parabolas to your curve. And that's even better than trapezoids. That's called Simpson's rule, but we're not going to do that. That's crazy stuff. That's what you would use a computer for. So, but we're going to talk about trapezoid rule here in a second. But first of all, I do want to do a practice problem. That was a good question, by the way. Let's see. If f of x equals negative 3x squared plus 1. Actually, let's do, I'm going to do negative x squared plus 10. I want you to find the area from negative 3 to 1 using, let's do midpoints. And I'm going to ask for 4 rectangles. So let me know if you have any questions. 4 rectangles using midpoints from negative 3 to 1 for this function. It would look something like this. I'm not claiming this is a good parabola, but let's take a look. Maybe I should have done those dashes in a different color. It's not a big deal. Remember, if you want to do like negative 3 squared, that's negative 9. You square the 3, then you negate. It's not square the negative 3. It is not that. So order of operations, exponents comes before multiplication. A negative out front of a number is considered multiplication. Y'all still working? You could even do this with circles instead of rectangles. It would be a terrible idea, but it's possible. It's kind of crazy to think about. Your question about circles, wouldn't they be too small? Or wouldn't this be too small to do circles? It would be completely absurd to do it, but you could fit the biggest circle you can, first of all, something like this. And then again, the biggest circle you can. Biggest circle you can. See what I mean? It would be ridiculous, though. Yeah, ew is correct. Anybody else still working? Are we done? Can you let me know if you finished? Done, done, done. Sweet. Okay. So, negative 1 squared plus 10. Okay, so wait. Sorry. So, for rectangle 1, the x value should be negative 2.5, negative 1.5, negative 0.5, and 0.5. So I'm going to use my calculator here. So, negative x squared plus 10 y1 of negative 2.5, I get 3.75, (7.75), 9.75, and 9.75. So each of these rectangles are just 1 wide, so that doesn't even really matter, right? And so these are the heights, the 4 heights. I get 3.75 plus 7.75 plus 9.75 plus 9.75. So times 2 plus 7.75 plus 3.75. Did we get 31 units? And actually, let's see. The actual area, y1, x, negative 3, 1. Actual area is 30.6 repeating. That's actually really crazy because we only did 4 rectangles. I didn't expect they would be that accurate. That's really nice to see. you did the width as 0.5. That makes sense. Cool. Okay. So do we feel pretty comfortable with this now? As like tedious as it might be, do we understand how this works? So I didn't even draw my rectangles, but I think you guys know what's going on. Whoops. Looks something like this. Okay. So let's talk about trapezoid rule. Let's not do it with a line. Will that suffice? Yeah, that's fine. I'm gonna bolden it up though. Let's see. And I think you'll see why I bolden it up. Oh goodness. Okay, that's good enough for me. Sweet. Okay, so we're gonna approximate this curve with trapezoids. What do I want to do? What are we gonna call this? F of x equals one second, let me find something that kind of matches this. I should have made something first. So let's do x squared minus 2x plus 6. And let's do from sorry, I'm going to change this 6x and 14. X squared minus 6x plus 14. Sorry, guys. Okay, and we're going to do this from what? 1 to 6. Seems fine by me. So let's do 1 to 6. And let's just do 5 rectangles. Let's do 5 rectangles. So we don't really have to worry about the width. 1, 2, 3, 4, 5, 6. Those look close enough. So the idea here is that, I guess I'll do these in, let's do blue. I'm going to take this up to the curve on the left side and the right side. But it's not going to be a rectangle. I'm going to connect these two dots so we actually have a trapezoid. Do you see how accurate this is already? So much better. We'll talk about how to actually calculate the area of this trapezoid here in a moment. So this would be f of 1, f of 2, f of 3, f of 4, f of 5, and f of 6. Like, this is so crazy accurate. Okay, so all these widths are 1. And the way you, so if we know, we're not going to figure out the area of a trapezoid from scratch because we'll remember it as soon as I tell you. If you know both of these heights, you just average them and multiply them by 1. Does that make sense? We're going to average these two heights and multiply them by 1. So here I get 1 is my width for everything. So let's do rectangle 1. So A is 1 times average my two heights, f of 1 plus f of 2 divide by 2 times the width. There it is, right? So now I'll do rectangle 2. This would be f of 2 plus f of 3 divided by 2. Let me do rectangle 4. This would be f of 3 plus f of 4 divided by 2. I think I kind of see a pattern here. I'm going to save my time actually. So instead of just taking a 1, all these are going to be halves as well. So why don't I take out a 1/2? And then it would be f of 1 plus f of 2 plus f of 2 plus f of 3 plus f of 3. Notice everything after the first one, there's 2 of them. There's 2 f of 2s, there's 2 f of 3s, and there's 2 f of 4s. F of 4 serves as the right boundary of this trapezoid and the left boundary of this trapezoid. All of them will be doubled except for the first and the last. So A is 1/2 times f of 1 plus 2 f of 2 plus 3 f of 3. Sorry, plus 2 f of 3 plus 2 f of 4 plus 2 f of 5 plus f of 6. This will give us our trapezoid sum. Any questions about this? 1 is the width, the half is because we're averaging these two, and the reason there's 2 of all of these is, remember, they're doubling up. Each of these boundaries on the inside, except for the first and the last, serve both as a left boundary and a right boundary. That's why there's 2 of them. So are we good? X squared minus 6x plus 14. You can put this in your calculator and you can just ask it. You can literally ask your calculator, what is f of 1? If you need help with this, let me know. So f of 1 is 9. F of 1 is 9 plus 2 f of 2's. F of 2 is 6. Plus 2 f of 3's, f of 3 is 5, plus 2 f of 4's, f of 4 is 6, plus 2 f of 5's, f of 5 is 9, and then just one f of 6 because it's at the end, plus f of 6 is 14. So we've got A equals 1/2 times 9 plus 12 plus 10 plus 12 plus 18 plus 14. 12 plus 18 is 30, 40, 52, 66, 55. So A is 55 halves, or 22.5 units squared. So let's actually check. I'll calculate the proper area. So this is what we found. We do from 1 to 6. Wait, did I miss something? 9 plus 12 plus 10 plus 12 plus 18. Oh, I totally added those wrong. This comes out as 37.5. I missed something. 12 plus 18 is 30, 40, 52, 66, 73. It's 73 halves. 75 halves. Oh yeah, okay. I'm just having a stroke over here. It's fine. So A is 75 halves. Or 37.5. And the actual area, the real area, is 36.6. For f of 1, you plug in 1 to the equation from earlier. And what I have is, I have the equation saved in my calculator, so all I have to do is type y1 of 1, and it gives me 9. I can show you guys how to do that sometime. Otherwise, you have to do it by hand. Just plug it in. So f of 1, you plug in 1. 1 squared minus 6 times 1. So 1 minus 6 is negative 5 plus 14. It's 9, like we said earlier. Does that answer your question, Jalen? Does anybody have questions about trapezoid rule? Okay, so let's see. Let me actually put that back up. No, I don't want to save that. I want to show you something. Let's see. This is going to be part of your homework. Where'd it go? Okay, you can see that. Wonderful. So I'm going to ask you to find the area between 0 and pi of the first little arch of sine, right? And I've actually, this is showing visually what trapezoid rule does. So black is the actual sine curve, and green is trapezoid rule with width 0.4. And I mean, visually you can see how accurate it is. So I just thought that was really pretty and that I would show you all that. So what there is there's a picture of this exact graph on the portal, and I'm going to ask you to do rectangles of width 0.4. So the first 7 rectangles will be that wide, but the last rectangle won't be exactly that wide. Not rectangle, but trapezoids. So make sure this last trapezoid is calculated on its own. And then as for finding these values, just eyeball them. So at 0.4, it's between 0.35 and 4 and more towards 0.4, so I might say 0.39, right? And so at 0.8, it's between 0.7 and 0.75, so I might say 0.72. Just give it a rough guess. It's not a big deal. And you have the y-axis here on your left to do a visual estimate. And if you need, you can have a ruler, like so if x equals 1, then you can put a ruler across, and so you get y equals 0.84. And the ruler will help you actually make the proper measurement, but even that, not necessary. Just give it a good eyeball. So this is one of your problems. The picture is on the assignment description. There's like 4 book problems in addition. So the book problems are all rectangles. This is the only trapezoid rule. So if you forget trapezoid rule, I would just go back to the notes. Any questions? All right, and we're not going to have a quiz this weekend. I think y'all are probably fine with that. All right, have a great weekend. Thank you so much. Peace, y'all.